Imagine this. A small object built by humans has been traveling through absolute darkness for nearly half a century. It has already left the solar system, crossed the boundary where the sun's influence fades away, and now moves through a place where there is no familiar light, no warmth, no sense of home. This is Voyager 1, and right now, at this very moment, it is still moving farther away from us, without stopping, without turning back. To truly feel the scale, try to imagine the distance. Voyager 1 is now more than 15 billion miles away from Earth. That's about 160 times farther than the distance between Earth and the Sun. If you tried to drive there at highway speed, around 60 miles per hour, it would take you more than 17 million years to get there. A commercial airplane flying non-stop would need around 2 million years. Even if you could travel at the speed of a bullet, it would still take tens of thousands of years. And light, the fastest thing in the universe, takes more than 20 hours to reach it. This is no longer just far. It's a scale so extreme that the human mind struggles to process it. And if you simplify it even more, every distance in your daily life becomes meaningless in comparison. The distance between cities, between states, even across entire continents, it all collapses into almost nothing next to where Voyager 1 is now. Even Earth itself, with all its oceans and land, becomes just a tiny reference point inside this scale. This isn't a journey you can imagine taking. It's a space you can only exist within. It was launched in 1977, at a time before the internet, before smartphones, before modern computing as we know it. People were recording music on tapes, and digital technology was just beginning to take shape. And somehow, it's still working. Its signal takes over 20 hours to reach Earth, which means every time we receive data, we're looking into the past. We're hearing what happened nearly a full day ago, while the spacecraft itself has already moved even deeper into the unknown. But the most powerful part isn't the distance, it's what it carries. On board is the Voyager Golden Record, a gold-plated disc designed to last for millions of years. This isn't just an archive, it's an attempt to preserve the essence of humanity itself. Encoded into it are images, the structure of DNA, the human body, the development of life, cities, roads, nature, water, light, moments of existence. It's an attempt to answer a question that may never be asked, but one we chose to answer anyway. Who are we? There are sounds of Earth, wind, thunder, rain, ocean waves, footsteps, a heartbeat, laughter, even a kiss. Something simple but deeply human. There are greetings in 55 languages, including the message, "Hello from the children of planet Earth." It's not just information, it's an attempt at connection. The record also carries music, from Johann Sebastian Bach to Ludwig van Beethoven, along with traditional music from cultures all over the world. Different eras, different civilizations, different emotions, all compressed into a single object drifting through space. It wasn't created to be analyzed, it was created to be felt. And one of the most extraordinary details, we tried to explain how to use it. Engraved on the surface are instructions, how to rotate the record, how to extract sound, how to decode the images. The unit of time is defined using the transition of a hydrogen atom, something universal, something any advanced civilization could understand. There's also a map of pulsars, a cosmic address that reveals where this object came from. This isn't just a message, it's an attempt to be understood. Behind this mission were real people. Engineers and scientists from NASA and the Jet Propulsion Laboratory built a machine that was expected to last a few years, but instead survived for decades. The astronomer Carl Sagan pushed for the inclusion of the Golden Record, insisting that if we were going to send something into the cosmos, it shouldn't just carry data, it should carry meaning. It was a rare moment where science and philosophy merged into a single object. The spacecraft itself is a combination of simplicity and brilliance. At its core is a central body filled with electronics. Attached to it is a large dish antenna nearly 12 feet in diameter, responsible for sending an incredibly weak signal back to Earth across billions of miles. Extending outward are long booms holding scientific instruments, positioned away from the spacecraft to avoid interference. Its onboard computer is extremely primitive by today's standards, less powerful than a basic calculator. And yet, that simple system has managed a mission spanning decades. Originally, Voyager 1 carried 11 scientific instruments: a magnetometer to measure magnetic fields, detectors for cosmic rays coming from deep space, plasma analyzers to study charged particles, imaging systems that captured detailed photographs of Jupiter and Saturn, instruments designed to detect radio waves, ultraviolet radiation, and energetic particles, all turning the spacecraft into a flying laboratory moving through the cosmos. And because of these instruments, we learned things that were once only theoretical. We discovered that the boundary of the solar system is not a clean edge, but a complex interaction zone between solar wind and interstellar space. We directly measured an increase in cosmic ray intensity beyond the heliosphere. We observed how magnetic fields behave in the space between stars. This wasn't just exploration. It was the expansion of human knowledge into regions we had never reached before. Over time, many of these instruments have been shut down. The cameras were turned off in 1990 to conserve power. Some plasma instruments stopped working. Engineers gradually disabled heaters, backup systems, and anything not absolutely essential. Today, only the most critical instruments remain active, those that still allow us to gather data from interstellar space. Voyager 1 doesn't rely on solar panels. Instead, it uses a radioisotope thermoelectric generator. Heat from the decay of plutonium is converted into electricity, but that energy is slowly fading. Every year there is less power available. Engineers carefully manage what remains, shutting down systems one by one to extend its life. Sometime in the 2030s, it will go silent. Right now, it is traveling through interstellar space, beyond the heliosphere, in a region where the sun's influence no longer dominates. The temperature around it is close to absolute zero, about -454 degrees Fahrenheit. The density of matter is almost non-existent. It's not just empty, it's a level of emptiness that's difficult to truly comprehend. And still, its instruments continue to send data back to Earth, real measurements from a place humanity has never physically reached before. But even when it goes silent, that won't be the end. It has no destination, no final stop. It will continue moving forward through inertia alone. In tens of thousands of years, it will pass near another star. In hundreds of thousands of years, it will still be traveling. In millions of years, it may still exist, long after the civilization that built it is gone. And there's something else that makes this mission even more powerful. Voyager 1 was never designed for eternity. It was meant to be a temporary instrument. But instead, it became the most distant and long-lasting messenger humanity has ever created. It has outlived technologies, generations, entire eras, and it's still moving. During its flyby of Saturn, it captured one of the most important images in human history: a tiny dot suspended in a beam of light. That's Earth. Every human who has ever lived, every story, every conflict, every achievement, contained in something almost invisible. That image became known as the pale blue dot. And maybe, more than anything else, it explains why this mission matters. Somewhere out there, in complete silence, a human-made object is moving through the void. Inside it, the sound of laughter, the rhythm of music, the voice of a planet that once existed. It doesn't ask for a reply. It doesn't expect to be found. It simply carries a message. And maybe, one day, something will find it and play that record. And for the first time, somewhere in the universe, what will be heard is not a signal, but a life.